Hello, students. Welcome back again to today's episode. Today, we are going to learn about matrices. So we say matrix is a triangular array of numbers which can be subjected to certain mathematical operations such as addition, subtraction, and multiplication. Matrices are denoted by capital letters of rows and columns. A 2 by 2 matrix is a square array of four numbers A, B, C, D arranged as follows. That's row 1, we have A, B. Then row 2, we have C, D. Alright. The numbers in the matrix are called the components or entries. So let's take matrix A for example. Matrix A, we have A, B, C, and D. So the A, B, C, and D, they are the components or the entries. All right. So we can see that matrix A is a 2 by 2 matrix. Why is it a 2 by 2 matrix? It's a 2 by 2 matrix because we have two rows. We have two rows, and the rows are A, B, and C, D. Yes, these are the two rows. And at the same time, we have two columns. We have two columns. And the columns are AC, AC, and BD, making it what? A 2 by 2 matrix. Alright, so simply we say that a matrix is a 2 by 2 matrix when it has two rows and two columns. Then matrix B, we say matrix B is a 3 by 3 matrix. So with respect to the explanation given to the 2 by 2 matrix, if you have two rows and two columns, definitely 3 by 3 matrix also states that what? If we have three rows and three columns, so we can see from here that we have row 1, row 2, and row 3. At the same time, we have column 1, column 2, and column 3, making it 3 by 3 matrix and a 3 by 3 matrix with three rows and three columns. Then matrix C, with matrix C, we have A and B, making it 1 by 2 matrix. So it is 1 by 2 matrix because we have one column each. So we have one column which is we have one row. We have one row which is AB. We have one row which is AB, and we have two columns which is column A and column B. All right. Then matrix D is 2 by 1 matrix. It is 2 by 1 matrix because we have two rows and one column. We have two rows and one column. We have row 1 and row 2, and we have one column. That's how come we had a 2 by 1 matrix. All right. So without wasting my time, we move on to quality of matrices. Equality of matrices. So equality of matrices, equality, equality, equality of matrices, or equality of matrix. So when you say equality of matrix, simply mean that equating matrices to their corresponding component in the other bracket. Yes, equating matrices correspondingly to their other component in the other bracket. All right. So that's that. All right. So the next one, it says what? Two matrices are said to be equal when their corresponding components are the same. So when their corresponding components are the same. So let's say that we have matrix A. Matrix A. So matrix A equals to A, B, C, and D. Then and then we have matrix B. Matrix B, which is B equals to X, Y, V, and Z, giving us matrix B. And we say that what? Two matrices are said to be equal when their corresponding components. So the takeaway here is corresponding components are the same. When the corresponding components are the same. So first we need to check the type of matrix. So here we have what? Matrix A is a 2 by 2 matrix. So matrix A is a what? 2 by 2 matrix. Then matrix B also is a what? 2 by 2 matrix. So therefore this satisfies what? This satisfies the statement that corresponding components are the same. Yes, they are the same because matrix A has 2 rows, 2 columns, and matrix B also has what? 2 rows, 2 columns. So therefore the members correspond to each other. So small a X, corresponds to X, then C corresponds to Y, then B corresponds to V, then D corresponds to Z. So therefore, we will say that A equals to X, then B, A equals to X, and B and C equals to Y, and B, D equals to V, and D, and D equals to Z. So therefore, we can say that they are what? Each component corresponds to the other. Each component corresponds to the other. Alright, so let's one example and see. So we have example one. Example one. So example one. Example one or trial one. We have matrix A, which equals to 3x plus 1, 7. Matrix A, which equals to 3x plus 1, 7. And 2xy plus 3 and 2x plus y and 3. Then matrix B also equals to equals to equals to equals to 10 3x minus y, 10 3x minus y and 8, 3, 8, 3. So we say that what? Two matrices are said to be equal when their corresponding components are the same. So when the corresponding components are the same, then we say that solution. We say that the above matrix is a 2 by 2 matrix. Yes, so this one is a 2 by 2 matrix. Then this one also is a what? 2 by 2 matrix. Why? Because it has what? Two rows. So this one is row 1, row 2. And it has two columns, column 1, column 2. The same applies to this row 1, row 2, column 1, column 2. Alright. So therefore they correspond, or the components or the entries corresponds to each other. So you get 3x, you get 3x plus 1 equals to 10. So if 3x plus 1 equals to 10, we solve it. Well, let's name it equation 1 or equation x or equation asterisk. Equation asterisk. So we are going to get 3x, 3x. Then we group like them. So the 1 will cross the equal to sign, so it becomes negative. 3x 10 minus 1. We are going to get 3x equals to 9. So x equals to 3. X equals to 3. From equation asterisk, we've known that x equals to 3. So now the next one is 7. 7 corresponds to 3x minus y. So 7 equals to 3x minus y. We call it equation A. So with equation A, we know that x equals to 3. So but x equals to 3. Therefore, we substitute 3 wherever that we find x. So we are going to get 7 equals to 3 by 3 bracket close minus y. So we are going to get 7 equals to 9 minus y. We group like terms. So y will be equal to 9 minus 7. Hence y equals to 2. Y equals to 2. So now we know for yes, sir. So now we know for equation asterisk, or we know the value for x, which is 3, and the value for y, which is 2. So we can go on and say that 2x plus y, 2x plus y, which corresponds to which corresponds to 8. So we are just inserting the values of x and y to check that whatever that we had is correct. So 2 bracket 3 plus 2. We are going to get 3 to 6 equals to 8, right? So 3 times 2 is 6 plus 2 equals to 8. Hence, our values for x and y are correct. Alright. Now, the next thing we'll be doing is addition and subtraction of matrices. So addition and subtraction of matrices. Alright. So addition and subtraction of matrices. Add or subtract a matrix, we only add the corresponding element. So like we did for the equality, we did what? We equate the element or the component to their corresponding members. So the addition and the subtraction, we also use the same routine or the same procedure. Two matrices can be added or subtracted if the number of entries on the row is the same as the number of the entries on the column is the same. So let's take an example. We have M, matrix M, 2, 10, 4, 5. Matrix M. So M, which equals to 2, 10, 4, 5, and matrix N, which is 1, 4, matrix N. 1, 4, negative 3, 3. Alright. Then the question says that what? We should find M plus N. So M plus N, M plus N will be equal to brackets. Let's look at the corresponding 2. 2 corresponds to 1. So we're going to get 2 plus 1. Then okay, so this one, the plus looks like 4. Let's clean it and write it well. 2 plus 1. Good. Then we have 10 plus 4. So 10 plus 4. Then we have 4 plus minus 3. So 4 plus minus 3. Or plus minus 3. Then 5 plus 3. Then 5 plus 3. Close your brackets nicely. Good. So we see that M plus N will be equal to 3. 4 minus 3 is what? 1. Then 10 plus 4 is 14. Then 5 plus 3 is 8. So 10, M plus N will be equal to 3, 14, 1, and 8. this is easier, and I'm expecting each and every student to grab this once and for all. The good students will be taking note of whatever we are doing now. So now this question says we should solve for x in the matrix equation x plus matrix 1 4 negative 3 3 equals to 9 4 negative 3 6. So with this, we are having equality and at the same time addition and subtraction. So let's see how we are going to do this. So example 2. So with example 2, we have x. So example 2, we have x plus matrix 1 4 negative 3 3 equals to 9 4 negative 3 6. 9 4 negative 3 6. Right. So let's get back. So we are going to get, let's group like terms first because we want x to stand on its own. So solution. Solution. So you get x to be equal to 9 4 negative 3 3 6. This one, it was crossing what? It was crossing, it is positive and it crossed and equal to, it becomes negative. Minus 1 negative 3 4 3. So x equals to big bracket. So we are subtracting according to the corresponding components. I'm going to get 9 minus 1, then negative 3 minus 3, negative 3 minus 3, then we have 4, corresponding with the 4, another 4 here, minus 4, then 6 minus 3. So we are going to get x equals to 8 negative 3. Negative plus negative is positive. So negative 3 plus positive 3 is 0. 0. 4 minus 4 is 0. Then 6 minus 3 is 3. And close your bracket. So therefore the value for x is 8003. Alright. So the next thing we'll be treating is identity or unit matrix. Identity or unit matrix. So with the identity or unit matrix, we have unit matrix for 2 by 2. And for 2 by 2 matrix, 2 by 2 unit matrix, it is represented as 1 0 0 1 1 0 0 1. And for the unit matrix for 3 by 3, We have 1 0 0, 0 1 0, and what? 0 0 1. Then the next one is 0 0 matrix for 2 by 2. So 0 matrix for 2 by 2 is 0 0 0. All the entries or the components are what? 0. Alright. So we move on to multiplication of matrix by scalar. So multiplication of matrix. Multiplication of matrix by scalar. So multiplication of matrix by scalar, we say that if K is a scalar and M is M is a 2 by 2 matrix, if K is a scalar, so if this K is a scalar, M is a 2 by 2 matrix. So 2 by 2 matrix, we can have A, B, C, and D. You can also choose to represent it by numbers or any variables, because it says what? 2 by 2. And 2 by 2, we need 2 rows. That is, this one is row 1, row 2, and 2 columns, column 1, column 2. Alright. Then Km will be equal to, so therefore, Km. So if you are being asked to find Km, you are being asked to find Km. If you are being asked to find Km, definitely it means that what? K is going to multiply M. So Km will be equal to K, which is the scalar, will multiply the entries or the components in matrix A. So we are going to get Ka, Ka. So we are going to get, let's expand it first. I'm going to get K by A, C, B, and D. So we are going to get Km to be equal to Ka, Kc, because K times A will give you Ka, K times C will give you Kc, and K times B will give you what? Kb. Good students. Then K times D will give you Kd. I hope we are grabbing it gradually, and eventually we will get there. So let's try some of the examples here. So trial questions. Good students will be writing the examples down. Then they'll be looking for more in the comment section. They'll be looking for more questions to answer or more questions to ask in the comment box. Good. Trial questions. So we have 3 trial questions here, and we are going to solve everything. So first one, matrix A equals to matrix A. Matrix A equals to 5, 5, -2, 3, 0, 5, -2, 3, 0. And b equals to 5, -1, 3. b 5, -1, 3. So sorry. 1, 3. Alright. And the question says you should find what? Matrix C. So matrix C equals to 3A minus B. So matrix C, which is equals to what? Then C equals to 3A minus B. So therefore, C will be equal to 3 brackets 5, 3, -2, 0, minus 5, 1, -1, 3. Please, are you following? And if you have any question, kindly input it into the comment section and it will be answered as soon as it is being sent. Alright, let's continue. So 3 becomes a scalar. So over here, 3 becomes a scalar. So C will be equal to, let's multiply. 3 times 5 is 15. 3 by 5 is 15. Then 3 by 3 is 9. 3, 3, 9. 3 times -2 will give you -6. Then 3 by 0 is 0 because any number times 0 is 0. Any number times 0 is 0. Good. Then we have our matrix B, which is 5, 1, -1, 3. Good. So matrix C will be equal to 15 minus 5, then 9 minus 1 for the first columns. Then we get -6 minus -1 because we already have -1 coming. Then 0 minus 3. So we are going to get C equals to C equals to 15 minus 5 will give us 10. And 9 minus 1 will give us 8. Then negative will give us positive. So -6 plus 1 will give us 5. Then 0 minus any number or 0 minus 3 will give us what? -3. So therefore C equals to 10, 5, 8, -3. Alright, so let's move on to the next question, which is number 2. We have A to be equal to -4, 3 to -5. A equals to -4, 3, 2, 3, 2, -5, bracket close. Then b equals to 2, -3, 7, -6. Then b equals to 2, -3, 7, -6. 7, -6. If you have any question, you insert it into the comment box. So what are we finding? We are finding 3a plus 2b. So we are finding 3a, 3a So you are finding 3a plus 2b. Alright, so solution. Let us not forget that over here we have two scalars and the scalars are 3. The scalars are what? The scalars are 3 and 2 because they are multiplying matrix A and matrix what? B. Alright, so 3a plus 2b equals to 2 bracket -4, 2, 3, -5, bracket close, plus 2, bracket 2, bracket 2, 7, -3, -6, bracket close. Oh, sorry, here is not 2, it's 3 rather. So 3, yes, because this one is 3, alright. So equal to, so 3a plus 2b will be equal to what? 3 times -4, we are going to get -12. Then 3 times 2, we are going to get 6. Then 3 times 3, we are going to get 9. 3 times -5, we are going to get -15. -15 plus the 2. So 2 times 2 give us 4. 2 times 7 will give us 14. 2 times -3 will give us -6. Then 2 times -6 will give us what? -12. So if you've been following very well, you could see that we are building on whatever that we started earlier in the beginning. We are just building on it. It's not anything different. So this will be equal to this one we are adding. So we say when we are adding, we add we can add when the members or the numbers in the matrix A, they correspond to the matrix in the matrix B. All right. So this one we have 2 by 2 matrix. So addition, we are good to go. So -12 first plus its corresponding number, which is 4. Then 6 plus its corresponding number, which is 14. Then we have 9 plus its corresponding number, which is -6. So 9 minus 6, because negative is stronger than positive. Then we have -15 minus 12, because negative is stronger than what? Positive. So therefore 3a, or let's change our marker, 3a plus 2b equals to -12 plus 4 give us -8. -8. Then 6 plus 14 will give us 20. Then 9 minus 6 will give us 3. Then -15 minus 12 will give us -27. So our final answer for 3a plus 2b will be equal to -83, 20, -27. Alright. So our next question is 3p minus 3 with the matrix, or 3 multiplying the matrix 6 to 3 -1 equals to 4 multiply matrix 3 -3, 0 -3, and we have been asked to find p. So let's see what we can do. So if you don't understand anything, or you want to share any reaction, kindly input it inside the comment section. Every comment will be reviewed. Every comment will be replied. Thank you for following board engineering. So 3p minus 3 bracket open 6231 3 -1 equals to 4 brackets 3 0 3 0 -3 -3, and we've been asked to find e. So solution. Wow, matrix is very interesting. Very, very interesting. So we are going to get 3p equals or minus. You can choose to expand the bracket first before you group like terms, or you group like terms before you expand the bracket. So let's group like terms before you expand the brackets. We are going to get 3p equals to 4 bracket 3 0 minus 3 minus 3 plus 3 bracket 6, 3, 2, -1. Alright, so now we can expand our brackets successfully. We can expand our bracket successfully. Now we get 3p will be equal to 4 times 3 will give us 12. And 4 times 0 is what? 0. Because any number times 0 is 0. And 4 times -3, we are going to get -12. Then 4 times -3, we are going to get -12. So we close the bracket plus 3 times 6. We are going to get 18. Then 3 times 3, we are going to get 9. 3 times 2, we are going to get 6. Then 3 times -1, we are going to get -3. Good. So over here, we practiced the scalar method. Now we are moving on to the addition method. So we are going to get 3p will be equal to brackets 12 plus 18, because 12 corresponds to or with 18. So 12 plus 18, then 0 plus 9. 0 plus 9. And the next one is -12 plus 6. Then -12 minus 3. Why minus 3? Because the 3 is negative and negative is stronger than positive. So 3p will be equal to 12 plus 18 will give us 30. Then 0 plus 9 will give us 9. Then we are going to get -6, because -12 plus 6 will give us -6. -6. Then -12 plus -12 minus 3 will give us -15. -15. Bracket close. But we want p, not 3p. So we divide both sides by 3. So we are going to get p equals to 1/3 39 -6 -15. Yes, the denominator 3. 3 is a factor of 30, is a factor of 9, is a factor of 6, and is a factor of 15. So we can divide through. So therefore, p will be equal to 3 will go into 30 10 times. So you get 10. Then go into 9 3 times. Then to go into -6, -2 times. Then go into -15, -5 times. So therefore, p equals to 10, -2, 3, -5. Alright, the next one is multiplication of matrices. Don't forget that what we did earlier was multiplication of matrices by scalar. By this one, we are doing what? Multiplication of matrices. So multiplication of matrices. Kindly subscribe to the channel for more videos that will boost our understanding in engineering mathematics. And more videos also will be uploaded very soon. So please stay tuned and subscribe to our channel, Board Engineering. So multiplication of matrices. We say that if A and B are two given matrices, where matrix A equals to AB, CD, and matrix B equals to P, Q, R, S, then AB equals to the component in A multiplying the component in B. So this is what we are trying to say. If matrix A equals to A, B, C, and D, C and D, good, and matrix B equals to P, Q, P, Q, R, and S. Then we say that AB, will be equal to the component of A, which is ACBD, multiplying the components of B, P, Q, R, and S. Alright. So therefore AB will be equal to, note that with this there is no scalar. So when you take component A, you multiply it with the first column, then you take component B, you multiply it with what? The second column. So they correspond with the multiplication. Each component or each element corresponds to the component in the other, or the component they are multiplying in the next bracket. So we can say that AB equals to A times P plus B times R. Then A times Q plus B times S. Then we have A times C times P. So you're going to get C times P plus D times R. Then you take C times Q plus D times S. And that's all that we need to do for multiplication. So you multiply the first row by the first column. So you multiply the first row by the first column, then you add them together. So you will multiply A by B, B by R, then you add them together so that you can get the unit matrix 2 by 2, or you can get the matrix 2 by 2. All right. So let's take some examples. So if A, so example 1, trial Q, which is trial questions, we are going to get, so if A equals to, bracket open, negative 2, 3, 1, 2, negative 2, 3, 1, 2, then B also equals to B equals to negative B equals to 2, 3, and B equals to 2, 3, and B equals to 2, 3, or 3, 3, 2, 3, or 3, 3, 2, 2, sorry, and B equals to 3, 2, and B equals to 3, 2. Then we can say that AB, then say that AB, then say that what? AB equals to negative 2, 1, 3, 2, bracket close, bracket 3, 2, bracket 3, 2. So someone may ask, why is it that this time around we have matrix B to be only, for matrix B to have, or matrix B to be a 2 by 1 matrix? Yes, it's a 2 by 1 matrix, and we can multiply. And our answer should give us what? A result of 2 by 1 what? Matrix as well. Our results should be what? A 2 by 1 matrix. So we are going to get AB will be equal to bracket to negative 2 times 3. Negative 2 times 3. Please, when you are doing this, be careful, because it needs much attention, else you might make a mistake. Plus 3 times 2. 3 times 2. Good. Then we have 1. We have 1 times 3. 1 times 3 plus 2 times 2 times 2. Always make sure that the number you are multiplying in the second column, they will be in line. Yeah, so if you look at the 3, we've been using the first entry or the first component in matrix A, multiplying the first component in what matrix B. And we are getting the same thing in line, the same last number in line. Yes, it's only the first entries that differs, but that of the second entries that you are multiplying, they do not change. Even if it's a 3 by 3 matrix, they are not going to change. They will be in line. So always check that to make sure that the work that you are doing the right thing. Alright. So we are going to get AB to be equal to 2, negative 2 times, you are going to get negative 6 plus 3 to 6. Then 3, 1, 3 plus then 3, 1, 3 plus 2 by 2, which is equals to what? 4. Which is equals to 4. Good. So AB, AB, AB. So AB will be equal to negative 6 plus 6 will give us 0. Then 3 plus 4 will give us 7. So AB will be equal to what? 0, 7. And now we have a what? We have a 2 by 1 matrix. Alright. With the next one, the second one is what? BA. 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 So with BA, we cannot do it because we cannot multiply. Since B is a 2 by 1 matrix and A is what? A 2 by 2 matrix. B is a 2 by 1 matrix and A is a 2 by 2 matrix. So we cannot do what? We cannot multiply. We cannot what? Multiply. So hence, BA cannot be what? Cannot be multiplied. Cannot be multiplied. Hence, we multiplied since B since B is a 2 by 1 matrix. It's a 2 by 1. It's a 2 by 1 matrix, but A is 2 by 2. Alright. Let's see. So our next example, we have X. We have S. Example 2. So with example 2, we have S. We have S. And S has some delicious entries. And the entries are 3, 2, 4, 6. 3, 2, courses. And then I'm reminding you that if you have not subscribed yet to Board Engineering, kindly do it for more mathematics updates. With Board Engineering, whatever difficulties that you are facing in mathematics will become easier, will become easier, become easier. All right. Then negative 312. Then we are finding what? ST. We are finding ST. So ST equals to 3, 4, 2, 3, 4, 2, and 6. Then T is 2, negative 3, negative 8, 12. So ST equals to 3 times 2 plus 2 times negative 3. 2 times negative 3. I will advise you that when you take the first column, use it to multiply. When you take the first row, use it to multiply the first column. Before you proceed to the next column. So let's finish the second one first. So with the second row, you have 4 times 2 plus 4 times 2 plus 6 plus 6 bracket negative 3. All right. Then we are done with the first column. That's this one. We are done with the first column of matrix T. So let's move on to the second column. So we are going to get 3. The second column, let's change our pen, ink. So we are going to get 3 times negative 8 plus 2 times 12. 2 times 12. Then we have 4 times negative 8 plus 6 times 12. 6 times 12. Please, are we following? The good students will be noting some of the examples down for additional practices on their own. So xt will be equal to, let's do our multiplication and addition. 3 to 6 plus 3 times negative 2 give us negative 6 minus 6. Let's put it in a nice bracket. And 4 times 2 is 8 plus 6 times 3 is negative 18. So we put it in a nice bracket. Close the bracket. Then 3 times 8 will give us negative 24. Plus 3 times 12 will give us 24. Are you seeing what I'm seeing? I'm happy with whatever that we are doing here right now. I think you're also happy only if you are following. Math is very interesting. So we are going to get 4 times negative 8. So that's going to give us negative 32. Plus 6 times 12. Then 6 12 is 72. Good. Now let's do our addition and subtraction. ST equals to 6 minus 6 will give us 0. Or let's change our pen's ink to make it look more attractive. 0. Then 8 plus negative 18 will give us negative 10. Then negative 10. Then negative 24 plus 24 will give us 0 again. Then negative 32 plus 72 will give us what? 40. Gives us 40. Then this is our value for ST. This is our value for ST. This is our value for ST. Our value for ST. Our value for ST. Or, yes, this is our value for ST. 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 Yes. So, another question. We set ourselves another question because we change the values here. These values here, they've been changed. So let's change them here. Let's change them here. So here should be 4 now. Let's make here 4. Let's make here 4. And let's make here 6. Yes. So that's that. So this becomes our value. This becomes our value. We are done. So we are done for the day. We are done for the day. We are done for the day. Thank you for paying attention and thank you for subscribing. Don't forget to subscribe to Board Engineering for more mathematical teachings, for more engineering teachings, like strength of materials, like measurements, and the likes of estimation. Watch out for the next episode, because in the next episode, we are going to learn how to find the determinant, how to find the event inverse, how to transpose a matrix, and how to find the adjoint of matrix. Thank you very much. Have a nice day. Bye-bye.